Welcome to your second lesson. It's called Homecoming Help. And tomorrow with your teams, you're going to work through this problem here. So what I want you to start thinking about is a way to determine a method to find the number of tables needed given a certain number of students attend the homecoming dance, assuming each table is completely filled. So for this task, we're going to use hexagonal tables. And as you can see, there are 6 people to a table. And in the diagram, we just represent them with red dots. But here's 1, 2, 3, 4, 5, and 6. And if they were sitting at that hexagonal table, this is where each of them would be. So obviously there's 6 people who can sit together at one table. But then as soon as you join the tables together, unfortunately you can't have anybody sit there. So we're going to have a different amount of students who could sit at that table. But as you can tell, it's not just going to increase by 6 each time. So what I want you to start thinking is, okay, if we can represent each of those each of those students with dots. Let me copy this. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 students could fit at 2 tables. And of course, you could have just counted the dots in the diagram from above. If we repeat that process, when I put that third table there, unfortunately, this student can no longer sit here. So we're going to add 1, 2, 3, 4, 5. And so if we wanted to know the number of students at 3 tables, we'd have 1, 2, 3, 4, 5, 6, 12, 13, and 14. So 14 students here. Obviously, there's a lot more than 14 students at Stevenson. So the question is this: if there were 1,000 students coming, or if half the school was coming, which would be around 2,200 students, how many tables would you need? That's what I want you to start thinking of for tomorrow.